All right, so my recording does appear to be working. Okay, so let me start back at the beginning. All right, so the website that I sent out in the link, and just so that you guys know, most of my stuff I post on GitHub, and my user ID on GitHub is just Melinda Higgins 2000. So it's all one word, all lowercase, and then I usually, all of my data and stuff and everything's like here. But you don't have to know that. Just if you're interested, you can download pretty much all of my stuff off GitHub. But I'm putting together this little spot for all these different workshops. I'm going to go back and populate this with all of my old workshops too. It's just for now, this gave me a place to stick them for this summer. And so this is the stuff we're doing today. And just so you know, then June, the workshop that we did, the recording for it is here. I'll come back later and add the code. I just hadn't compiled what I had put together last time because a lot of it was more just talking about the software and the infrastructure, and I only did a little bit of coding. So, hi, come on in. We're just getting started. It took me a minute to get my recording working. So you didn't miss anything. So I put this together, and there's a couple things on here before we sort of dive in. So there's a great data set, which is just, it's a lot of fun to play with, and I've been using it in my 736 class, which I'm teaching again this fall. So for those of you that are interested in continuing to see stuff and learn stuff, I'll be updating this course website throughout this fall, and I'll be cleaning this up a little bit more. But like all of my lessons are out here, and all of these lessons have code for SAS, SPSS, and SAS. So when I teach this, I teach the students, and they can come in with whatever software that they want to use. The only one that I'm not promising to support at this point is Stata, because we don't have a site license for Stata, so it's a little hard for me to get. And two, the bulk seems to really be either SAS, SPSS, and now we got a lot of people learning R. So, question. So this is the quantitative analysis of clinical research. It's been on the books for years as an elective in School of Nursing. I picked it up like 8 years ago. George Katsonis used to teach it. It basically used to be like the SPSS course. So for all the students that took BIOS 500 and 501, they learned SAS, and they would come over to nursing. Everybody wanted them using SPSS. So this used to just basically be an SPSS course, to take everything you learned in 500, 501, translate it into SPSS, and add a project and just, some additional work that you don't really get a chance to do in 500 and 501. And the last few years that I've done it, I was like, why do we force people to, they already know SAS, just keep using SAS. If you want to keep using SAS. If you want to learn SPSS, that's fine. So I just sort of opened it up, and I still stay with the standard topics. The other thing is this course adds longitudinal analysis, and I do a little tiny introduction at the end on factor analysis and like a little bit about psychometrics and just some of the modeling that you don't get in BIOS 500 and 501, because in both of those introductory classes, you don't get any longitudinal modeling, you don't hardly get anything on multivariate, and it's stuff you really need. So, yep. Are y'all in that together? No?
I'm starting my first.
Oh, okay. All right.
I started with Aaron and Nicole.
Oh, okay. Cool.
But I told them they wanted to take like an intro to statistics course, and I'm like, I've taken like 5 of them, and I'm not taking another one. So they said I could put in something else. So I'm thinking this would probably be more usable.
That'd be great. I think of. Yeah, there's like a. Yeah. So. So I do start with data cleaning and basic statistics. It kind of hits all those same points. It takes the content of what you did in 500 and 501, puts it into one semester. I add additional multivariate modeling, but the real key of this course is taking all of that, and then it's like, okay, I know how to do a t-test. How the heck do I apply it to my research question, write up the results? So the focus is on really sort of moving all of this into application and making it really work for you as researchers, as opposed to learning the statistics for the statistics' sake. Anyway, so yes, Gia went through the course. So I'm hoping that we can eventually sort of morph this. I don't know. There's still that a whole ongoing conversation about, do we keep doing BIOS 500 and 501? Do we restructure the first year? It all comes down to funding, but we'll see.
For the CPTR? That's what I'm getting out of it. Not that I think he's fine, but I understood that it was a lot of focus on some really basic stuff. And okay. I mean, that's great, and I probably could use a refresher, to be honest. Yeah, because Jessica told me that it was similar to what she's describing this class, but she didn't tell me like the concepts that they go over. Jump? Yeah.
Yeah. I love Jump. Jump, actually, the cool thing about Jump is it has an interface very similar to SPSS. It's very point-and-click friendly. Well, that's true. But under the hood, it's done by the same people. It's basically done by SAS. So it's very SAS friendly. But the big thing I love about Jump, and I don't know enough, I plan to ask the guys at IBM next week when I'm at JSM, what their plans are for SPSS, because the one thing that Jump has that nobody else has is the ability that when you're in the data set, it has the data table and the graphics are linked. So if you're over here looking at a scatter plot, you can like circle a bunch of points and those points get highlighted in your data set, and vice versa. You can highlight things in your data set and it'll show up in your plot. There actually is an R package out there that will kind of do some of that, but it's a little bit of a pain to set up. I think it uses Java, which I hate dealing with Java. Anyway, but that's one thing I love about Jump. But yes, it's not free. We don't have a site license for it. Again, anyway. Licensing. Anyway, but the reason I mention this is that under these lessons for this course, if you click on any of these, like so for example, there was a lesson on Univariate and a lesson on Bivariate. I pulled some of the stuff for today from these lectures, and so the lessons are posted, and then the GitHub repositories that have like the data and the code and stuff. So anyway, so the bottom line is this stuff's out here. You guys are welcome to use it, download it, etc. So that's one thing. The other thing is, when I was teaching that course, I started using this data set called HELP, which is short for Health Evaluation and Linkage to Primary Care. And so the information on that data set is here. Oops, I'm sorry. If you click on that, that downloads the data. And I'll talk about that in a second. But to learn about the data set, let me bring that up, is here. And this is from a book that they wrote called SAS in R, which is a really good book. If you know SAS and you want to learn R, this is a really good book to get. And then I've got links out here, or they have links out here for the data set in all these different formats. We're going to be using it in R, but they have it in Stata, SAS, comma delimited. The code book is out here. There's a whole bunch of good information out here on the study and so forth. But anyway, so this is the data set I was going to have you guys sort of work with today. But yes, if you click here, it will download on. So in Google Chrome on mine, it downloads here, for example, and I can show you. For me, it shows up automatically in my downloads directory. And I'll show you what we're going to do here in a minute to move it. But eventually, we're going to put this in our project directory. So let me just say a few more things. The code for today is linked here. So if you click on this, it'll actually just open in a window because this is an R script. And I talked very, very briefly about this last time. So just like in SPSS, you can write a syntax file, and in SAS, you can write a .SAS program. Anyway, it's just text. So from the website point of view, when you click on it, it just opens. If you want to download it to your hard drive, you can right-click and then say save it where you want to save it. Is it not working for you? Oh, okay.
And then when I install packages, it can't move.
I got to show you how. I'll show you that here in a second. So hold that question. All right.
It just loaded a bunch of dependencies.
Well, some of that, but I can show you one of the issues. It turns out. Do you have?
I'm there.
Okay, so this is a weird bug, and it only shows up in Windows. I went ahead and put the link here because this comes up so many times. No. And it's a known problem with the antivirus software. And so I've mentioned this in previous workshops, but basically on Windows with like the Emory owned equipment, McAfee's installed, all of that. When you download an R or you go to install an R package, what it does is it downloads the compressed file, sticks it in a temporary folder, unpacks it, and then installs it where like our RStudio wants to find it. Problem is that read-write happens so fast, it looks like it's under attack. So this is the fix, and you go in and you change the sleep setting. So I can come around. Let's just try it. Okay. So if you haven't already, go ahead and open RStudio, and we'll just take this step by step, so I don't get too far ahead of myself. And I'm gonna I'm gonna close. Let's see.
I need to go back and organize. Like I'm really bad at organizing all my millions of files.
Well, I'm glad you said that. So one of the things with just in general, actually this is true for, it doesn't matter what software package you're working in. This is true with SAS, SPSS, R, etc. It's always a good idea to create a new folder for each project. So for what we're doing today, and you can define project as big or as small as you want. Like I tell people a lot of times, especially with your dissertation, I would probably create a folder for each chapter or for each key segment of the analysis, or the focus of the different questions and stuff like that. Like I try to create one for each class, or I create one for each workshop, that kind of thing. So once you've got it, RStudio open, if you come in here and say File, New Project. So this is I would always start with a new project. And if you've already got an existing directory created that you like, you're welcome to use that. For the purposes of what we're doing in these workshops, I'm not going to talk about version control, but if you wanted to set up version control and link it to something like GitHub, you could go through here. But for now, let's just say a new directory. And for what we're doing here, we're just going to do new project. But just to let you know, there's a whole bunch of other options down here. I mentioned briefly that you can use R in RStudio to build websites. There's a thing here if you want to build a new website. You can build a book. I'm playing with that too. But for what we're doing, I just click new project. And then give your directory a name, like we'll say workshop 2. And let's see, where do I want to stick this? I think I created one last time. How did I do this? Tell you what, I'll call this R Workshops. Where'd it go? I lost my directory. Hold on one second. Okay. So like say we've got something called R Workshops, and so we've got that folder. It's going to create a new directory called Workshop 2 under R Workshops. So just come up with a system that works for you, but I would all go ahead and just create a new project. You can have multiple sessions open, just FYI. Just to keep it cleaner, I usually leave this unchecked. That way there you don't have 8 different windows open. And just click Create Project. And so I did show this briefly last time, but just to reiterate, when you do that, it's actually now created a new folder on your hard drive. So like with here, like if I go to R Workshops, Workshop 2. So now this is where it is on my hard drive. So you could do this on like a cloud account. You could do it on your USB drive. You could do it to the S drive or the T drive, or if you're in school public health, there's an H drive, which is like your home drive. And so when it creates, you've now got that folder. The other thing you'll notice over here in the Files window is notice it says C R Workshops Workshop 2. And if you kind of highlight it, it'll show you what folder you're in. So one of the things that I've seen people do when they first start using R is they'll put their code one place, the data is stored somewhere else and you constantly have to write all of these like long file paths so that you can find and save. It's just easier to put everything in one directory and just work in that directory. And then you don't have to worry about, you know, sending pointers out everywhere. And it's kind of like organizing your work directory in SAS, that kind of thing. Okay, so now that we've got this created, let me go back to the workshop page. So if I'm here, if I click on that link for the data, it downloads this help.rdata file. And like I said, on my computer, by default, it downloads into my downloads directory. So I'm actually going to cut this and move it here. The other option you can do is if you right-click and say save the link as, and then you can make sure you can go find the that Workshop 2 folder that you created. I'll give you guys a second to do that. And this is an interesting, while you guys are doing that, just to let you know, the data set here, let me see if I can bring up the code book. No, that's the publication on it. Hold on. Let's see, contents. Oh no, that's the book. The data set. Oh, that's all of the instruments. But there was a more descriptive. Okay. Well, anyway, I was thinking that they had something that was a little more descriptive of all of the different pieces in the data set. It must not be here. Anyway, but it has some really good information. Has it collected data on mental health. They collected data on there's some biological marker data like BMI and that kind of stuff, and they followed people over time. So it's got some good longitudinal stuff, which we won't get into today. All right, were you guys able to download the data set? Yay! Okay, cool. So you got the data. The next thing to do, same thing with the code script. So if you right-click on this and say Save As, let's figure out where I stuck this. So our workshop 2. So the code here, it just says Univariate, Bivariate, or unibivariate.r. And so this is the R script that we're going to work with. So you guys will have the R code and you can go back to it and play around with it. So now that we've got those two things downloaded, you ought to be able to see it back in RStudio. So you'll see 3 files, the R data itself, the R script, and then this workshop2.rproj. That's just basically the project. It has minimal information. If I click on this, it actually just brings up project options. So I right-clicked on it and then clicked Save Link As, which it may look a little different depending on which browser you're using. I think if you just click on it, it just opens, but it won't actually download. In theory, if you did click on it, you could cut and paste from here, but in general, it's never a good idea to cut and paste code because sometimes you can end up with wonky formatting and then the computer code like crashes and you're like, why is this not working? And anyway, so it's just better if you have the raw file. And I listed the packages here, so most of you guys probably know. So when you install R, R is just a basic language. And it has some built-in functionality, but it really is the bare bones. It's kind of like, the best example I've heard is it's like, you know, you get your phone, but if you want to do anything with it, you have to add apps. So it's like that. You're downloading base R, and then you got to add additional functionality. Oh, there's a lot of stuff you can do with base R that's already built in. But there's so many good packages out there that there's a lot of these that will install. So really the only two that I would say for sure, dplyr and ggplot, are important for what I was going to show you guys today. These others are like I'm just going to show you some different options. HMIS is literally a collection of miscellaneous functions, but so many people use it now. I almost feel like it should be renamed, but everybody knows it as HMIS. So it's really good. The psych package is a very good package. It actually has a ton of stuff for doing psychometrics. So if you're doing factor analysis, reliability, a little tiny bit of SEM in there. PASTE CS, I can't remember let me see what this description was. Regularization, decomposition, and analysis of space-time series. So no idea. But it's got some neat summary statistics functions that I wanted to show you guys. Gmodels is another one that as a kind of a collection, it just has various tools for model fitting. But it has a really good cross-tab feature for doing like frequencies. The CAR package has nothing to do with cars. It actually is short for the Companion to Applied Regression by John Fox. And if you plan on doing much with statistics modeling in R, I highly, highly recommend this book. Just anything he does. He's a fantastic statistician. He loves R, and he's written a lot of really good packages. As a matter of fact, he's the author of the R Commander interface. And I'm thinking when I do the regression workshop next month, introducing you guys to that. You guys took my class. I always talk about it in class. And it actually is a GUI interface for doing regression and other modeling from R. So it's actually, and you can get some point and click capability, which is kind of nice. But those are the main ones. These others just have some neat little plots and stuff that I was going to show you. E1071 is another one that cracks me up because it literally is a collection of stuff that was put together from this group. And I don't know why it was called E10. I guess it may be Engineering 1071. Maybe that's the course title. Yeah, so, but so many people know it, they've never renamed it. And then these are just some interesting little plots and stuff. So, all right. So now that we've got this here, just to show you the install packages, which is under tools. So this all comes from CRAN, and I talked about this last time. So CRAN is the Comprehensive Repository for R something. Okay, hold on. I can remember what CRAN stands for. Comprehensive R Archive Network. So this is probably one of the best places to download packages for R. And by default, it's set up when you're in RStudio that you're pulling from this repository. For those of you that are doing things more in the biological sciences, so metabolomics or the microbiome, you're probably going to pull a lot of packages from Bioconductor. So Bioconductor is also a fantastic repository for R packages, but most of those are just sort of focused on processing biological data. I wish they would add an interface. I'm not really sure why you can't add Bioconductor to here, but Bioconductor has to have its like own plugin to then download and install Bioconductor packages. So there's like an added layer. But we're not going to talk about that today. So anyhow, but in here, if you just start typing these in, it should show you pretty much everything that's in CRAN. I think there's now over 12,000 packages in CRAN. So it's pretty amazing. But like for dplyr, if you click on this, and I'm going to go through this so that you can see this error. By default, there should be a default library. There are ways to change this. I usually don't mess with it. But you can override some of these settings, and by default, it should install all dependencies. And so if you click install, again, I'm on a Windows system, so this will look different for the people that are on a Mac. Okay, so on mine, it goes, warning, unable to move temporary installation. So this is that bug that I was mentioning back here. So if I open this, and it took me a while to figure this out. This hit me in Thanksgiving last year. I went through an upgrade, and it was due to this antivirus thing. So it turns out if you run this little command, this trace utils, sorry, back here on the little website that I put together, there's a button that says resources, and there's a link here for fix installing packages. I should say on Windows. I think if you're on a Mac, and if you're on a different Windows system with a different antivirus, you may not have this problem. So, but let me just show it for the purposes of what's on the recording here. But this trace utils thing, and this only works for the current R session. So the reason I mention this is that if you do this and leave and come back, you have to go through this process again. So this automatically opens something called this unpackaged zip file. And down around line, I have this memorized now. It's like line 140, there's this command here, the system sleep. And if you change it from a half a second to 2 seconds, it sort of usually fixes the problem. And you click save. And it doesn't actually, it only saves it in memory. It's not actually changing the file on the hard drive, which is why you have to do it every time you open R. But once you have a package installed, you don't have to reinstall it. Unless you upgrade or something else. Okay. So if yours worked, then great. I'm just doing this for the purpose of the recording. All right, so I'm going to run that install packages. This is the actual command that gets generated when you're in the tools install packages. So I'm just going to run that command again. Hopefully this will work. Mine's already installed, but I'm just showing you guys this so you'll see it. This is what you want to see. It should, so it said it successfully unpacked, and then instead of giving me the error on the moving, now it says downloaded binary packages in. And so showing that it worked, over here in the package window, if you scroll down, and you'll have different lists of packages. That's okay. You should see dplyr listed as a package. If you don't see dplyr listed as a package, then something went wrong. The other thing to notice while I'm here is notice it says version 0.7.6. So that should be the current version as of what's in CRAN today. Now, every now and then, if you've got code and maybe haven't touched it in 6 months, you come back 6 months later and run it, you may get a little note saying there's a more updated version. So up here at the top, there's a little button that says update. And it will come back and tell you, like, a lot of my packages are out of date because there's a lot of these packages I just don't use all the time. So I can come through and I could say all, that'll take forever. Or you can select 1 or 2 and then click the install updates. So that's one way. Usually updates install without an issue. I've not had the update bug, but anyway. Yeah. So take a minute and make sure that dplyr and ggplot for sure. And if you want to try some of the others, go for it. So I'm going to give you guys just a minute to do that. I'll leave these up here. And if you're having problems, let me know. Okay, cool. All right. There is, while you guys are doing that, I'll just show you this Stack Overflow article. By the way, if you haven't, Stack Overflow is an place where you can post questions and find answers. It's kind of like Google for software programming specifically. And a lot of times if you Google for an error or a problem that you're having with R, 9 times out of 10 you're probably going to get linked to a Stack Overflow answer. So this is where I found this, and this is classic. A lot of times if you type in unable to move temporary installation, this is what you'll get. Turns out this posted, 7 years ago, back with Windows 7. So it didn't hit me until I was in the middle of Windows 10. I actually thought it was Windows 10 update. But I finally figured out that no, it's a virus software issue. But down here is the answer. This is the first thing to try. It says run this and then look for line 140 and change it from sleep 0.05 to sleep 2. And that's what I did earlier. If for some reason that fix doesn't work for you, because I've had some packages where sometimes it doesn't work. There's another one down here where you can run this debug thing. Problem with that is every time you install, you have to go through the debugger, and it's really slow. So I hate doing this, but every now and then, usually one of those two fixes it for me.
Why haven't you switched to Linux?
Because it would make me too non-standard. I mean, there's so many people that I support that if I move to Unix, I'm just going to look that much weirder and different. So I just haven't, although I keep moving more that direction because now I'm learning LaTeX and all of that stuff. So I was between that and maybe getting a Mac. But I'm such a Windows. I mean, I started out in DOS, so me moving to a Mac is such a mental shift. But that said, one of the first mass specs I ever worked on was a Mac operating system, so I had to learn Mac to be able to run mass spec, which is interesting. So, if like when I had this problem last semester, I gave up and just got my personal computer and brought it in because then I didn't have any like research data on it. So I was like, I just took the virus software off and then it was fine. It's the virus software that screws it up. It's not Windows 10. Anyway, okay, so let's dive in. All right, and as we go, if we hit problems, you guys just holler at me. Okay, so that's the nuts and bolts of we got the data, we've got some code, and we've got the packages installed that we need. And I'll apologize. I've been trying to be better about this, but I just didn't have time to get it all compiled today. Usually when I write an R script, I try to list at the top, these are the packages you're going to need. So I'm trying to get better about that. So I didn't. I sent it late in the email. Sorry about that. So this is a compilation of some of the stuff I was doing last year when I was teaching 736 for the Univariate and the Bivariate lectures. That's kind of where this is coming from. And then all an R script is really is just a text file. So anything that starts with a hashtag is a comment. So all of this is just comments. And I encourage you guys to add comments as you're putting together your R scripts. That way there you'll remember. So don't just assume you'll remember what you did 2 days ago, 2 weeks ago. So I'm trying to be better about documenting. All right, so we created a new project. We've got a new folder. This is your working directory. And so one way to check this, there's a function here called getWD, which stands for Get Working Directory. And I just put this in here so that you can see if you run that command, it'll come back and tell you where you are on your hard drive. And this is really important because for this workshop, we're not importing or exporting anything. But if you were, if you just said read a file or export a file, this is where it's going to go. And so if you get an error at some point, like on your projects, and it says I can't find a file, odds are it's because it's looking in the wrong spot. So if you ever get a message that says can't find such and such, run the getWD command and try to make sure that you're where R thinks you are. Does that make sense? Okay. And the R data set, I spent a little time last time showing import and not so much export of data, but R data is a proprietary format to R. So it's binary, but it's really efficient, loads fast in memory, takes up a little bit of space. So for those of you that are working microbiome, metabolomics, that kind of thing, if you can get your data sets compiled and then saved as R data files, they should be more memory efficient. Now that said, if you're really truly big data, you may have to move to the cloud. So that's one limitation of R. There are some packages coming down that are going to make this better. Data table is one. But basically, if your data won't load into memory, you're really not going to be able to work with it in sort of desktop-based R. There's cloud resources, and I've been talking with Vicki about what we could do to maybe stand up an R server here, at least for the purposes of teaching, which would solve some of these problems because at the beginning of the semester we could set it up, load all the packages, and then all the students have to do is log into the server. You don't have to manage all the software. But I think some of that pain is good, because, I mean, it is, because if you're going to walk away and you don't have access to that server and you want to set it up and run it yourself, you kind of need to know what to do anyway. Not that I'm wanting to torture students. So it's like, just how much pain do we want to inflict? Okay. And I did briefly show this last time, but under File, there is, in the newer versions of RStudio, which at least the last several versions, there's now a whole bunch of ways to directly import. So you don't have to learn all of the import commands, but if you can import from text, Excel, SPSS, SAS, and Stata. And just to let you know, about a month ago, I had a data set, a stated data set that I could not import into the latest version of SPSS, but I could get it into R. And then from R, I was able to save it out and then bring it into SPSS. I was like, okay, whatever works, right? So if you've got that, this is another way to get data in. Okay. So go ahead and run that load data set, and it'll load the help data set. And I mentioned this last time, so for those of you that haven't used R as much, when you load data, it shows up here in your global environments. This is a little bit like the work library in SAS, SPSS, sort of. But basically, this is temporary memory. So if I exit, anything in my global environment kind of goes away. There is a way to resave it, but for what we're doing today, we won't do that. But just know the data set shows up here. There's a little blue button here to the left. If I click on that, I can kind of scroll down. It'll show me the list of the variables. And then over here at the far right, there's a thing kind of looks like a little table. If I click on that, it'll actually open in a view window. And this really is truly just a viewer. You cannot edit the data from here, but you can do like some sorting. So like if I wanted to sort everybody by their CESD scores, you could click on that little arrow and it would sort them. And I think if you click it the other way, it flips and goes from ascending to descending. But it's not actually changing the data at all. It's just how you're viewing it in this window. And you'll notice there's a couple places where you see these little grayed out NAs. So there is missing data in this data set. And R by default labels these as NA, which means not available, I think. There is another code that's used. Sometimes you'll see NaN, which stands for not a number, which is a little bit different. But NA just means not available. So just know that's how R sort of highlights missing data. All right. So we got the data loaded. Yay. And the code. Okay. There's some really good functions, and I mentioned a few of these last time. So once you get a data set into memory, these are all really helpful. Class is something you can use on any object that's in R. And it turns out everything in R is an object. And I won't spend a lot of time on that. But basically, anything that shows up over here in your global environment window, you can run a class statement on, and it'll tell you what kind of data object R thinks it is. So in this case, the help data object is a data frame. And that's, I would say, 99% of the time when you're working with data in R, it's going to be a data frame. There's a few other little variants of that, but that's kind of the workhorse. Saying a data frame is almost like saying spreadsheet or database. The STR function, if we run that, it's going to generate a bunch of outputs. So let me make my console window here a little bit bigger. STR is short for structure. And in reality, what you're seeing here in the console window is almost the same thing that you see when you click this little blue arrow. So it turns out what RStudio did was it built an interface that when you click that, it's really running the STR function under the hood and then displaying the same information. And so like, for example, ID, which is the subject ID, that's an integer. PCS1, which stands for the physical component score of the SF36, I think, is numeric. Let's see if there's anything else down here. Most everything in here is integers or numeric. I don't think there's any character data. Say that again. So it's just like the data in the global environment except characters. Well, yeah. So when you click this little blue arrow, it's basically running this STR structure command, which is telling you everything that's inside the help data set. The only two that aren't listed, quote unquote, as integer or numeric is all the way down here at the bottom. There is substance and race group, which are factors. Factors is a are sort of a special case in R. There's pros and cons to factors. I tend to like them, but that's another one for a lot of people when you first get started with R. It's hard to wrap your head around because it kind of acts as both like character-based data as well as numeric. So it's kind of, for those of you guys that have used SPSS, and SPSS a lot of times will code things as 1, 2, 3, and then 1 is male, 2 is something else, that kind of thing. They map to different values. So that's kind of what a factor tries to bridge that gap. Okay, so that's that function. There's a couple of others, and I just mentioned these. Attributes is another one that gives you information on an object. And I'm going to scroll up because this one, it comes by kind of fast. So some of the attributes of that data set are the names, which are all of the variable names. It gives you the class, and it gives you row names. For the purposes of what we're doing, the row names here really don't matter. I typically try not to mess with it, but especially for those of you that are working with biologic data, especially the microbiome. I have worked less with some of the metabolomic programs, but in the microbiome especially, there's a lot of data that shows up in those row names, and sometimes those row names have to be mapped to certain things, otherwise you can't align like the species and the, I forget what the other part is because they're such multi-dimensional data sets. So some things show up in the column name, some things show up in the row name, and then it's like you have to match the row names. Anyway, so I just mentioned that. So row names can be really important depending on what kind of data you're working with. If all you want are the column names, there's actually a function just called names. And so if you run that, then you get a nice list. Oh, sorry. Run the whole command. You get all of the column names here.
Melinda, when I imported this piece of code, it came imported as a text file, but it isn't reading it as our script. It's keeping it as a text file.
As a text file? All right, let me take a look.
It's not getting all the options. It's not doing the highlighting.
Oh, okay. Oh, sorry.
If I do inspect, it opens it up.
Oh.
The code, but when I'm working with it over here, it's treating it as text. What have I done?
All right, go back to the website real quick, and oh, you're fine. I was just trying not to step on your code. All right, so right click and say save as. Okay, I just want to see what it's doing. Oh, okay. So at the end where it says file name, go ahead and type in .r. I think you just have to force it and then say save. Okay, and then go back to RStudio. All right, so now you have both univariate.r and univariate.text. So
open that one.
Yep.
Now, okay.
So what's happening is while that R script is just text, you have to put the .r like file extension on there. And then RStudio understands, oh, this is our code. So that hashtag is a comment. If it's reading it in as just a generic text file, then it doesn't kind of know what to do. So good point. So, and as soon as you change that extension, now it shows up and it has this little icon here in the file window. It has like a little thing with little R stuck next to it, and as soon as you open it, now you've got like different coloring for the commands. Like it helps you distinguish between, and right, yeah. So and it's a little bit pickier inside the RStudio interface for that. Like if you were in basic R, you should still be able to just highlight run files even from like a text file, because the code is the code is the code. So, but thank you for asking that, because yeah, that one's not as obvious. And sometimes when you right click and save as, like it tries to guess, and if you don't explicitly type in the dot whatever kind of file it is. Good question. Okay. All right, so that just tells you some stuff about the dataset object. These functions here, dim, nrow, ncolumn, do kind of what you would guess. Dim gives you the dimensions of the data set. So for people that have worked in SAS, this is similar to like proc contents, which gives you information on what's in the data set. And namely how many observations and how many variables. Now you can see that up here in the global environment, like it tells you there's 453 observations of 88 variables, but that DIM function kind of gives you that. In row gives you the number of rows. In column will give you the number of columns. Anyway, all right. So any questions? This is just getting information about what's in the data set. All right. So it's always a good idea. The reason I'm showing this is I think it's a good idea anytime you bring the data set in, run through a couple of these things and make sure that you've got what you thought you should get. So, because I've had things before where I import the data and know, okay, I'm supposed to have 50 variables and I got 45 for some reason. Or worst case scenario, you thought you were supposed to have 450 subjects, but you only see 300. Where'd they go? So just some of that kind of stuff. Just double check, make sure everything got read in like you wanted. There's another function called links that does different things depending on what you give it. So if you just tell it the whole data set, it turns out, because the data set has 453 rows, 88 columns, if I run length and I tell it to look at that whole data set, it turns out it actually just gives me the number of columns. It gives me the length of that big data set is 88. Well, 88 is the number of columns. If I pick an individual variable in that data set and run length, now it's going to give me the number of observations. And let me make a little note here. So to pick one variable in the data set, use the $ selector. So, so the syntax for picking or choosing a variable in a data set is the $. So I'm going to start typing this because this is one thing I love about RStudio. So the summary command is a great command. It goes through and runs like summary. Oh, sorry. Let me back up. Hold on. We'll do it up here. Okay. So suppose I've got the help data set and I want to pick, so I'm going to use the $. As soon as I pick that $, it now gives me the list of every variable in my data set. Now if you've got thousands of variables, this can get kind of long, but if you know that the variable starts with, say, P, now all I see are my variables that start with P. And like I know for sure I want to look at PCS. So it turns out in this data set there's 5 time points. There's a baseline and 4 other follow-up time points. So the numbers here are really which follow-up. If it doesn't have a number, then it's the baseline data. Hindsight, I wish they had called them like 1 through 5 or something. But anyway, so PCS1 is actually the second time point. It's the first follow-up time point. So that's one thing I like about R, is that $ selector. And then in RStudio, it allows you, it tries to be smart and tries to help you pick things, which when you've got a zillion variables, it's very helpful. So if I run the links command on one variable, now I get 453. All right, let me go back and fix what I had typed before. Yeah, so that's that summary command. All right, so this sort of starts the, initial univariate stats. So the summary command is built into base R, and it's fantastic. I could run it on the whole data set, but since I got 88 variables, it's going to fill up the console. So let's just look at it for one variable. So for the PCS1, it gives me just some really basic information. It gives you the minimum, the maximum. It gives you the first and third quartiles. It gives you the median and the mean. And here at the end, it tells me I've got 207 NAs. So I know for that variable, I've got 207 missing values, which it turns out actually that's about right. There was almost a 50% attrition at the first follow-up time point because there was 453 people at baseline. This is this whole idea of looking at linkage to care. These are mostly homeless, transient population that they're studying. So the fact that they couldn't find people wasn't surprising. The fact that they found more than half of them actually is a really good thing. So they were able to actually track them. And the summary command is a fantastic workhorse. It's a really good place to start. Again, make sure, look for typos, look for unusual outliers, that kind of thing. You know, if you know your data set's not supposed to have missing data and it comes back with a whole bunch of NAs, that's usually a sign that, oh, okay, something went wrong in my import. Like, I thought I was importing dates. they didn't import. Or like maybe there was something that went sideways when it was reading it in. It didn't know how to interpret it. I don't know so much about R, but I know with like SPSS and I think even in SAS, if it doesn't know what to do with it, sometimes it'll just set it to missing. I know SPSS will do that. So the other thing is you'll notice that while it does give us the mean, it doesn't give us the standard deviation. Bummer. Like if I had the standard deviation, this would tell me so much. And then I'd be done, right? Because I would have both my parametric summary, which is the mean and the standard deviation. I've already got the median with the first and third quartile. So if I was doing non-parametric statistics, I've now got what I need to report for non-parametric statistics. So just give me the standard deviation. So there are these built-in functions for getting specific stats in R. And you can kind of, I can't remember if there's a great way to look these up, but like if I'm in the help menu here and type in mean, it'll say this is to get the generic function for the arithmetic mean. I can't say that. Turns out you can actually get a trimmed mean. Any of you guys ever seen that? Know what a trimmed mean is? It's sort of like half a step towards the median. The median is a non-parametric. It's literally the center point of the data. It doesn't really matter what the extremes are. It just picks the midpoint. The trimmed mean is still a pseudo-parametric estimate of the mean, but it basically knocks off the top and bottom X%. So like if you know you have weird outliers, you can cut off like the top 2.5 and the bottom 2.5%, and then you kind of have the 95% middle of the data. So if I set trim equal to, this is the fraction of the observation. So you type in like 0.05 and it would trim 5% of the data and it would give you the trimmed mean. Anyway, so it's like a pseudo robustized statistic. The other thing I'll point out here is since we know we've got a bunch of missing data, we're going to have to tell R what to do. So there's this option here where we have to tell it what we want to do with missing data. By default, it does not strip out the missing data. And I'm going to show you what happens if you have missing data. So we're probably going to have to put something in there to deal with the missing data. So this is a pro and con that I have with R, is it forces you to deal with missing data, which it seems like such a pain at the beginning. It's like, why can't it just deal with it and give me the answer? But the fact that it forces you to do it makes you sort of deal with it, I guess. So anyway, so if I run the mean, it comes back and tells me the mean is missing because it doesn't know what to do with the missing data. If I scroll down here, actually it doesn't list. It lists weighted mean, some others. I was hoping that it would show me the standard deviation, but the SD is the function for standard deviation. There's also median is a function. Just add some of these here so you guys can see. Variance is another one. Anyway, there's a bunch of these like single statistics that you can call. But for now, if I run these functions, they're all going to come back as NA because I've got missing values. So why did we get the NAs? You guys saw this. There was 207 for this PCS1. So basically all we have to do is we now have to add an option here. And it's na.rm says, take the missing data and remove it, yes or no. So na.rm is like missing, remove, true or false. And so if the missing data. And so when I do this, now I can actually get a mean and a standard deviation, keeping in mind that this is the mean and the standard deviation, ignoring those 207 missing values. So the sample size on this is only 240 something. So that's one way to start getting and pulling out some different statistics. This is a little trick that I think is kind of handy figuring out how much missing data. I mean, you could write down the number 207 out of 453, you know, so we could actually calculate that, right? So there's 207 missing values, 453 original observations. So 45, almost 46% of the data is missing at this point, well, at least for this variable. It turns out that there's another function that's kind of nice, is this is.na. I'm going to run this one separate so you guys can see it. So what this does, I'm just going to run it down here. Well, all right, tell you what, we'll do it up here just so you guys can see the steps. It's going to look at all of these PCS values back over here, right, in the help data set, and it's going to scroll through these, and for each one, it's going to say, is this value missing, yes or no? And so it'll come back and give me a whole bunch of true falses. And so if I run this, I get 453 true falses. So basically, the first 1, 2, 3, 4, 5, 6 people don't have a PCS at follow-up time point 1, but person 7 did. And so the really cool thing about the is.na is it shows up, it's a logic question. So technically this is a logic variable it's creating as a whole bunch of true falses. But under the hood, R actually stores all of those as zeros and ones. So they're numbers. We can do like a sum function on them. And so if you do the sum of this is.na and run it, it'll come back and tell me there's 207 trues. Now, what did true mean? True meant that it was missing. So again, watch for that double negative stuff. All right. And you can use that if you take the mean of those zeros and ones. That actually will, and then multiply. So we could actually take this and then multiply by like 100 on the end to get the percent. So this is just a way that like you can start using the code to like kind of start pulling some of these different things out. And you don't have to do this. I mean, you could just make a mental note and come back and add it later to your report. But I just want you to see this, that there's some cool things you can do with some of these functions. And working with true falses as zeros and ones, there's some cool things that you could do like that. So anyway, all right, let me save that. Questions? Nope. Okay. The other functions, because like I said, in the summary function, we got the min and the max, and then we got like the first and third quartiles, and we got the median. If there's other percentiles that you want to get, there's a function in here called quantile. Not sure why it's called quantile versus being called percentile. Probably how it was developed, because it gives you way more than 5 quantile. I mean, you can get any percentile you want using this function. And so there's this argument here where you set probs equal to, and you can list out which probabilities you want to find. So let me bring up the help menu for quantile. So you give it which variable you want, and then the probs equals, and then you make a list. In this case, it's doing a sequence of values, but you can just use the little concatenate C function to give it a list. So this would give me the 2.5th and 97.5th percentile, which actually gives me the 95% in the middle. Sometimes that's it's actually sometimes interesting to do this, because then you can compare that to your 95% confidence intervals for the mean or something. So sometimes I play with this just to see what values I get. And again, since we have missing data, I still have to tell it what to do with the missing data. So that's why this NA remove is here. So this gives me like the 2.5 and 97.5 percentiles. So this is just some other ways to start pulling some of these different statistics out for doing descriptive analysis and stuff. All right. So other ways to summarize the data. I'm going to show you guys this because you're going to start seeing this more and more when you go out to the web. There's some fantastic tutorials that are out there. By the way, you guys probably know we have access to all the stuff under lynda.com. So if you go to lynda.com and click on login via institution, let me just bring it, lynda.com, not li. And I think if you click sign in, I'm already signed in via Emory, but I think if you do this, like it should come up and say, do you want to sign in using your institution account? If you do, then you can say, and then you have to find Emory, and then you like log in using your Emory credentials. I know it works for all faculty. I'm going to assume it works for students. I haven't. I think you just type in www.emory.edu. Try that. So yeah, which is at the home page, and then you get redirected, and it should be. So is that working? Awesome. So there's a ton of courses. I think there's now like, okay, so when I do it, it comes up like this. So I should be able to log in with my, well, through Emory, we have access to Linda, and it's free. Data Camp, most of the courses you can start for free, and then you have to pay something. For the people, I'm trying now for each of my courses to enroll my students in it, because I can enroll them for 6 months for free while they're active students. Well, Linda has a ton of stuff that has, they got a lot of things that don't even necessarily have to do with programming. Data Camp is, I think it's more in depth than Coursera and edX. Like I think if we typed in, for example, SPSS, like here's a whole bunch of SPSS training. Let's see. Let me type. Can I just type in R? Oh wait, R programming. So yeah, so you might just have to, like, here's a code clinic. I haven't checked these out. I just know we have access to it for free. Like here's one, SAS programming for R users as opposed to R programming for SAS users. Here's R for data science, code R clinic, data wrangling in R. Like I said, I haven't checked these out. Data Camp's another one. But anyway, so, but the bottom line is you're going to start seeing more and more of the tidyverse approach. And this is a slightly different approach to programming. And I didn't show it here, but if you just Google tidyverse, T-I-D-Y verse, Hadley Wickham put this together. Actually, it is Hadley and a couple of other people. But there's all of these different packages that are sort of built to interact with each other. dplyr and ggplot2 are the two I'm going to show you guys today, but you can click on packages and see all of these different ones up here. I eventually want to get to where I can teach people how to use purr, but there's all kinds of cat references, by the way, in R. Purr is one, four cats is the other one I love, which is four kitty cats together. It's a way for dealing with factors, and anyway. Yeah, I know. For some reason, it just seems to be a little more cat-centric. I'm not sure why. But anyway, so there's this whole idea, and the reason I point that out is you'll notice up here, for example, like when we did the sum statement, I did the is in A, and then I wrapped the sum around it. So in reality, what it was saying is, okay, go find all of this missing data and then find the sum. So it's like you have to start on the inside to the outside, which is fine if you've only got one or two layers here. But if you've got like 5 different levels of things going on, it gets really hard to read and follow and try to figure out what the heck people are doing. So the tidyverse approach, which uses these pipes, in this case, what it's saying is take this data set, select this column, and then run a summary. So this statement below is the same as saying take the summary of the help data after choosing the PCS1 variable. So there's really 2 steps, or actually 3 steps. Find this data set, select this column, and then run the summary. And the dplyr approach actually writes these out as individual steps. So it's a little easier to read. And for long programs, this is so much easier. So I'm trying really hard to kind of move this direction. but I want to make sure people get a chance to see some of the base R approaches because you're going to see that in tons of legacy code and examples too. So to get access to that, that's where you have to load this package called dplyr. And so that library, this is, I think, the first time I used the library statement. So with R packages, they get downloaded and installed. Okay, that just means it exists on your hard drive, and the R package or the R language can now see all of that functionality. But to actually use the functions, you have to load them into memory. And so this library statement loads the dplyr package and its functions into memory. So you have to run that statement.
You have to run it every time you're going to.
Yes. Yes. But you do not have to reinstall the package. Once you've got the package installed on your hard drive, in theory, you only have to do that once unless, as Jennifer said, you upgrade your machine and then you want to upgrade stuff and move things in. Anyway, if you get to that point, just so you guys know, there actually is a package. I'm going to say this for the people that are listening on the video. There's actually something now called install R, like install with the letter R at the end. And I just encourage you to read up on this. This is really good the next time you have to update R. And one of the questions that it'll ask you is if you want to move all of your packages from the old version of R to the new version of R. Basically, it just moves them on the directories on your hard drive. And that's kind of handy to do. So anyway, I just mentioned go here. You can click on the website link for rstatistics.com and read more about it. Anyhow. Yeah.
Do you ever, like, functions that you're going to run multiple times, do you ever set those, like, build it into?
You can. So, you're right, you're saving a script. Yes, you're saving a script here. You can take this a step further so that as soon as you open R, it by default does some stuff initially that you want to do before every session starts. And I think that goes into an R profile. I hesitate to do that because the problem is once you set that up, then you've forgotten that you set it up, and then you go to a new machine or you change. It's like, why isn't this working? And you're like, oh, yeah, I did all that customization, and now I can't remember what I did. And for the purposes of what I'm doing when I'm teaching, I try not to do it because then it's like hidden and you can't really see it. So the short answer is yes, there are ways to automate it, but we can talk further outside of this. But the library statement, it's always a good idea to have it. If it's already loaded in memory, it really doesn't hurt anything to like reload it. So I'll talk more about masking here in a minute. Just so that, well, actually I can go ahead and talk about it because it turns out in base R, you have base, package base, and package stat. So there are some functions in base R. One's called filter, lag. There's another one, intersect, set, diff, set, equal, and union. That now that I've loaded dplyr, dplyr also has functions with those same names. So keep in mind, CRAN has over 12,000 packages. Bioconductor has almost another 2,000. And then there's like an infinite amount on GitHub. So there is no function name deconfliction that goes on. I mean, you literally have hundreds of thousands of programmers across the globe writing code. So about the only thing that kind of gets deconflicted is the name of the package. Like right now, I don't know of any packages that are named the same name. But inside of packages are all these functions. So so what happens is you've got base R, and then you've got statistics, which is part of base R. When I load dplyr, it's a little bit of first in, first out. So at the moment, now that I've got dplyr loaded, all the dplyr functions are at the top. So if I was to type in lag as a function, it's going to run lag from the dplyr. It's not going to run lag from the base. Anyway, and I'll show you guys a couple other things as we get further down. All right, so to run like that same summary command that we did with base R above, doing the dplyr approach, I can now use this funky little thing that's called a pipe function, which is the % greater than %. That's just the syntax. I'm not going to explain why it's like that, but that's the syntax. So what this basically says is take the help data set, send it to or pipe it to the select function, go find this column in the help data set, then pipe that into the summary command. And so, I'm going to write that just so you guys can see it. So this is 3 steps. Get help data set, pipe it or send it into the select command and find a PS1 variable. Oops. Then run the summary command. And so if I run all 3 of those together, I'm pretty much going to get the same answer. It formats it slightly differently, but all the same data. You get the same exact thing you got if you just ran the summary command. But now it's just a little bit cleaner to read. And it turns out the select command here is actually coming from the dplyr package also. Send it. Send it. So I just give you guys a second to look at that because it's a little bit of a shift. But these pipe commands do make things a lot easier to read. And it turns out that select command, I can actually select multiple variables out of the data set. So this is a great way that, like, again, we're starting with 88 variables. Odds are I don't want to run summary on all 88, at least to get started. So suppose I wanted my baseline age, the physical and mental component scores, and then the CESD depression scores for everybody at baseline. So I can go in and just select those and then run those through the summary command. So now I've got summary statistics on those 4 variables. Now one thing it did do is it dropped the listing of the missing. I think because it's doing, actually I take that back. One of the reasons it doesn't, there is no missing data. This is all, the baseline data actually for all 453 was complete. Sorry. Yeah, the PCS1 was the first follow-up time point. That's why it had missing data.
So the structure of this is dataset, variables, selector variables, and then the function.
Yeah, in this example it is. I mean, there's all kinds of, yeah, in this example it is. But this is usually a good way to do it because you're sort of down selecting so that you're not running it on all variables. I mean, you could. I mean, I could easily leave this step out. I could run a summary, and it's going to give me the summary for all 88. So it's just going to take up a big chunk of screen. But anyway, but that's a good approach to use. So that's kind of the dplyr approach. There's some other packages, and if you've loaded these, great. If you didn't load it, that's okay. But watch what happens when I load the HMIS package. So there's a function in here called describe. And click run. It continues to mask some other stuff. So now that I've loaded dplyr, if I run HMIS, this SRC and summarize function, which I haven't shown you, those actually get masked because it turns out the HMIS package has those function names also. So one of the ways to deconflict these issues is to use a, I'll put a note here. Notice the masking warnings. Good idea. Use the package : function format. So there actually is a way to explicitly call the function that you want in which package. And so, for example, this function that I want to show you guys describe, I can type the package name HMIS followed by 2 colons and then the function. So what this does is it tells me I specifically wanted to run this describe function from the HMIS package. And for right now, I've got it running against just some different variables. And you guys can see what this looks like. So like if I ran it for age, it's actually kind of neat because it gives me some things. It says I've got 453 values. There's no missing data. There are 42 distinct ages, which is kind of interesting. can't remember what info is. There's the mean. Can't remember what GMD is. And then these are all percentiles. So this would be the 5th, 10th, 25th, 50th, 75th, 90th, and 95th percentiles in terms of ages. And then it's kind of nice. This gives me the 5 youngest people, and these are the 5 oldest people. So basically everybody's going from age 19 to 60 in this data set. Race group was a factor. So let's see what it does with a factor. Object race group not found. Okay, sorry. Let me highlight the whole command and run it again. So since race group was a factor, it actually gives me slightly different data. So it still tells me I've got 453 values, none missing. There's 4 distinct levels. Here they are: Black, Hispanic, Other, and White. So these are the counts, and then these are the percents, well, proportions down the bottom. So 46.5% are Black, 11% are Hispanic, 5.7 Other, and about 37% White. And then these are the PCS scores at baseline and at follow-up time point 1. And so again, it's just continuous data. It gives you the summaries. So this is just another good function. I really like it. Again, it starts giving me some stuff kind of like I see in proc univariate with lowest and highest and extreme values and all that kind of thing. And it turns out we can use a dplyr approach to run this describe function. So just like we did above, where we said help data, then come in and select these variables, and then pipe it into a function, I can use the hmiss describe function for those instead of the summary function. So if I do that, now I just basically get all of them. And the cool thing about this is it gives me a little bit cleaner formatting. Like it says, I got 4 variables, 453 observations, here's age, and then it does a dashed line, then here's the information for PCS, NCS, and the CESD. And
that format comes from dplyr, or because you asked for multiple variables?
I think it's because you asked for multiple variables using the hmiss function. So that's actually an output from hmiss, but yeah, that's a good question. A couple of others, because I know we're starting to run out of time. Pastex is another package, and there's a function in there called stat.desc for describe. Just to show you what that one looks like. It gives you this long sort of vertical, and there's got to be a way to turn off the scientific notation. but this says how many values do I have, how many are null, how many are NA, and so I've got 246 values and 207 are missing. And then it gives me the min, the max, the range, the sum, the median, the mean, the standard error of the mean, the confidence interval for the mean, the variance, the standard deviation, and the coefficient of variation, which nobody ever looks at. So it gives you a ton of stuff. Sure. Again, you can do this for one variable, multiple variables, so that this would just give it to you for all of those, and it kind of lays them out in columns. So now so there's some neat things you can do when you start playing with this and looking at formatting and stuff. The psych package, if you loaded that one, turns out there's another function in psych called describe, and it looks different than the hmiss describe. So that's why it's really important to have that package : followed by the function name. So if I run this one, you can see it gives you slightly different output. So there's univariate statistics. There's, as I say, a lot of ways to skin this cat. There's just a lot of different approaches out there. These are probably some of the more popular ones. Frequency tables. So most of these you have seen that if we wanted to, I think psych won't describe a factor, but we know that the hmiss will describe a factor, so like race group. But what if I wanted to get something that looks a little bit more like a classic sort of, here are the levels, here are the counts, here are the relative percents. So there's a package out there called gmodels that has a function in it called cross table. And so if I put in that race group, by default it formats it so that it looks like SAS output. So here's what the output looks like. And it turns out you can change the format to SPSS, and now it sort of looks like SPSS. I don't know. Anyway, but it has this little bit nicer sort of text formatting. There's some other univariate graphics and things in here that I've got. I won't probably go through all of these. So I know a couple people got to leave. I'll finish out the recording now. So to visualize some of these things, there's a hist base function in R that'll make a histogram. So for example, like here's a histogram of age. So it gives you the frequencies and then gives you the age values down here on the bottom. That's kind of nice, but a lot of times what you really want to see is the density. So instead of looking at the counts, like the relative, what you'd like to do is change this into relative percent. And so there's a function in base R called density, and then it'll go and pull those values, and then I can wrap the plot function around it. And if I do that, now I get kind of this like kernel density plot instead of the histogram. So sometimes it's kind of nice to trade these off and just see what you get. You can put the two of them together. There's another, so histogram is a basic plot in R. Turns out you can actually make the frequencies false. So by default up here, even though I didn't say it, the default in this is that this setting frequency is automatically set to true. That's part of the default. So if I type in histogram here, it'll say if plot equals true, the resulting object is plotted by, anyway, this step. But it gives you the counts. By setting it equal to false, then you get the relative percent, which is what we want if we wanted to look at density. So that density, I can also, instead of just using a plot command, there's another command in here, it's called lines. And what lines does is it takes the line and overlays it on the existing plot. So I'm starting to kind of bring in this concept of layers. So a lot of plotting in R is this idea of building layers. Like you have a base plot, and then you add stuff to it. And so in here, I've like main is the title, so I'm giving it a title, and then I'm changing the X label. And so this kind of cleans up the histogram. And just so that you guys can see it in RStudio, in the plot, you can click zoom and give it in its own window, like if you want to make it bigger so you can see what's going on. There's also this really awesome export function, so I can save it as an image. I can save it as a PDF, send it to somebody. I can copy it to the clipboard if I want to cut and paste it over into a poster or a paper. Odds are if you're doing like a paper for publication, I would come in here and say save as image, and then you can pick which image format you want. Guess what? There's TIFF and there's EPS. How many of you guys have gotten that for publications where they go, we need a really high density TIFF plot or an EPS, and everybody's like, what the heck's an EPS? It's encapsulated PostScript. Metafile is actually fantastic in Windows. That's a vector-based format in Windows. It's very high resolution. So if you're building PowerPoint, especially a poster, you probably want to save it as Metafile, and then you can bring it in, and then you can scale it to 2 feet by 2 feet if you want. It'll print really well. And you can change the height and the width and all that kind of stuff, and change where you want it saved. So that part's really powerful. I really like the graphics handling. Now that we have that, I can overlay a line, and all I'm doing here are adding some additional options. I'm not going to go through all this stuff, but this changes the color of the line. Line width is kind of the density, and so there you go. So this is starting to look a little bit like what you might get in SPSS or in SAS, where you want to overlay a line with the histogram and so forth. Yeah, sometimes it depends on whether it's like small or big, and yeah. There's some other cool little things. I don't know. These are things that you can't normally do in other packages. There's something called Rug that'll add little jitter points. It'll actually show you the density. So it's almost like if you did a dot plot underneath the histogram. Every now and then you'll see stuff like that. So this is where, base R gets confusing, because you kind of have to know which functions initiate a new plot window. So plot initiates a new plot window. Hist does, box plot. Some of the things that are sort of the basic, you kind of have to know. Lines adds to, rug adds to, anyway, which is one of the reasons why this is just some basic base R stuff. There's the ggplot2 approach. And this is, again, this is similar to dplyr with this idea that you build a basic and then you have layers on top. So, by the way, this also exists online. So this is the R Graphics Cookbook by Winston Chang. This is one of these that, like, you flip through it and you go, I want to make a plot that looks like this. And then he gives you a code example, and it's like, dude, I can adapt this for my data set. And then you can go make that plot for your data set. So here, you guys take a minute, flip through that. It's also online. So if you type, although I'll admit, sometimes the website crashes. But if you type in R Graphics Cookbook, well, there's the book itself, but if you go to this link here for Graphs Cookbook for R, the book is actually here if you want to go buy the book. But exactly. We'll see if this loads. Every now and then it crashes for me, but when you're on here, you can flip through and say, oh, okay, I think I want to do a scatter plot, and I want to add this to it. And the reason I mention this is because all of his graphs and stuff use this ggplot2 approach. And the site can't be reached. Okay, just try back later. It does work. I think whatever server he has it on just can't handle a lot of capacity, so sometimes it just times out.
So in the middle of the night, you go back.
Yeah, it's not that bad. Eventually it'll come back. So I'm going to load ggplot2. And so this takes a little bit, and I won't have, networks. Yeah. Oh, well. Oh, wow. So yeah, I just Googled it. Did it come up for you? It's cookbook. Oh, okay, that worked. Okay, so let me, so if I copy this, let's see if I can get the whole thing to come up. All right, let's see. www.cookbook-r.com. So let me see if I can get the base. Okay, so here's the basic, and these are roughly the chapters in the book. So, like, suppose that I know I wanted to make some kind of graph, and I want to make a bar and a line plot. Like, here's a whole bunch of examples. So, like you're looking through, it's like, oh, this is really cool. How did he make that plot? Well, the code is here. And so that's kind of where some of these approaches come from. And he's kind of moved to the tidyverse approach. But just to show you, like, to make a histogram, what ggplot does is it builds layers. And so the first command says, give me the data set. And this is a little counterintuitive. I had the hard time. An AES is an aesthetic. And so this is getting into the ggplot, by the way, stands for the grammar of graphics. And so the idea of aesthetic is that you build the graphic environment in which you apply aesthetics, I think is kind of how they think about it. But basically what this says is I want to take a variable age. That's going to be my primary sort of X variable. It's coming from this data set help data. This establishes the plot environment. So like if I run this by itself, just that one part, all it does is it creates a graphic window with nothing in it. It knows I'm going to be bringing in age, so it goes ahead and lays out the sort of min and max for age, but nothing's on top of it. So it's got, okay, we've got this graphic environment created. What do I want to add? And so the little plus here means add a geom, and a geom is a geometric object. So everything in ggplot starts with geom underscore something. So a histogram, if I do that, I add the geometric object of histogram. So there you go. And there's some other things here. And these are all just shown as examples. I won't have time to go into it. If you're interested, there's a new version of, I think, the ggplot2 book coming out. Hadley Wickham, and there's a ton of people that have stuff out there for ggplot. This is a fantastic one to start with simply because I find myself often just either flipping through that textbook or his website looking for examples. It's like, yeah, that's what I want to do. Show me the code. And then I can usually figure it out. And sometimes trying to start writing the code from scratch gets really complicated. So the code that I've got here is just some examples to kind of get you guys started. So like you could take my code and then just change out the variable name in the data set and use it. So this basically does kind of what I did above with the creating a histogram and then overlaying like a density curve. So, and then I've got the alpha here changes the transparency. So I've got like this little pink overlay on top of a white histogram. There's other things that you can do where you take the whole thing and you save it out into an object, and then you can take this little plotting object and add additional conditions. You can add themes. You can there's a whole bunch of stuff you can do. So this is just showing how you can break down those steps. Y'all want to keep going, or do you want to stop there, or take a minute and absorb, ask questions? Because I can keep going a little bit. Okay, I'll keep going a little bit. A couple things with the data subsets. All right, so I've kind of glossed over this because I talked about it last time, but this little less than followed by a dash is the assignment character. So you can take everything on the right-hand side and assign it to what's on the left. So what this is saying is it says take the help data set, run this select command, and I'm going to do a subset, right? So I'm going to pick out these 1, 2, 3, 4, 5, 6 variables. So I'm picking out age, gender, race, depression, and then the physical and mental component scores from the SF36. So I'm doing this sub-selection of these 6 variables, and I'm going to save it in a new subset called help set 1. And so when I do this, I'm actually going to have another object up here, but now instead of 88 variables, I've got 6 variables. So it's a smaller data set. Sometimes it's a little easier to work with stuff like that. So when I did that, there's a couple other functions that are built into, I think this is base R. QQ norm and QQ line are one ways to get sort of those like QQ plots. So here's whoops. The other thing is once we've got multiple graphs and figures built down here in the plots window, until you close out your session, every graphic that you've created is now over here in memory. And so you can kind of scroll through them. So here's a QQ plot with a reference line. So you can kind of tell that, and you can sort of see it here, right? That age looks pretty good. I mean, there's a few outliers out here in terms of older people. Really, the bulk of the data set, stops around 50, but we do have a handful of people above age 50. And so when I look at that normal probability plot, this tail is probably going to give me a little bit of skewness. And so what happens is you get out here to these older ages and these values fall off. But this isn't too bad. There's just a little bit of skewness there. If I wanted to do more formal testing of normality, actually take it back. Here's a couple of others. So like I said, these are options. So the car package has a function in it called QQ plot. This is another kind of QQ plot that you can get. The cool thing about this one is he always goes in and highlights specific things that meet the outlier criterion. So evidently observation 14 and 343 get flagged as outliers. There's another package, this ggpubr, that has this ggqq plot function, and it gives you the QQ plot with some confidence intervals. So take that as you will. You can do normality tests. This, I would take these with a grain of salt. All the normality tests are very sensitive to deviations, small deviations from normality, and sample size. So the bigger your sample size, more likely you're going to get a significant result for really small deviations. But that said, there is a function called the Shapiro test that you can run. And so just to give you an example, the p-value here is very small, 7.4 times 10 to the minus 6. So what this says is, yes, age significantly differs from normality, but does it really? I mean, it's small deviations. There's the Kolmogorov-Smirnov test. If these tests don't ring bells for you, that's okay. Yeah. Andy Field's book does a pretty good job. As a matter of fact, one of my favorite pictures in his book is he has this picture of Kolmogorov, the actual statistician, and he's got a glass, and it says Kolmogorov, enjoying a nice Smirnoff. Anyway, so, but this is another normality test. There's a couple others in here that I'm not going to run for now. If you've loaded that E1071 package, there's a function in there called skewness, another one called kurtosis. Some of these same functions are in the psych package. There's something else, I won't even go into these, something called Mardia, which looks at other distributions, marginal distributions. And again, the describe function, which you guys have already seen, actually goes ahead and gives you the skewness and kurtosis. But anyway, just some of those things. I've got some other examples here with that same code reiterated, just to look at if you wanted, instead of age, like you could look at the CESD, the PCS, and the MCS. So this is that same code, and the only difference that I've done here is basically I've got the plot, the QQ plot, and then the describe and the Shapiro test run for like the CESD. And then I do it again, that same block of code for the PCS. Like if I was going to do this over and over, that would be a good place to like write a function and then save all of that code, and then I could just run that whole series over and over for each variable or something. Like that's where you kind of get into like how do you start making your code really work for you, so as opposed to just kind of scripting things out longhand, brute force. So I'm gonna, yeah, and I'm still not the world's best about doing that myself. So this is just a quick example of like getting a summary with the paste stacks. Oh, this is how to turn off the scientific notation. I think that's what I did here, where now I get actual numbers and I don't see everything, you know, times 10 to the whatever. So that was just that fix. So box plot is another one, like histogram. That's a built-in. There's some things here, and I'm going to skip some of this, where you can actually go in and pull out all of the box plot statistics. Like if you really wanted to know the values of the hinges and the whiskers and all that kind of stuff, you can compare that to the summary function. There's actually a function in here called the 5-number summary, which gives you the min, the max, the lower hinge, upper hinge, and the median. I just think I love this in the notes. I point this out to students because this bit me in the behind one time, where I was teaching the students. They were all learning SAS, but I had done all of my lecture notes using SPSS. And I had an example on the board of a box plot with the numbers all highlighted, and all the students were like, we're getting different numbers. I'm like, okay. So I had to go investigate, and it turned out the default setting for the method for computing percentile between SAS and SPSS is different. And it's really minor. It depends on what kind of data you're working with. And it turned out the variable that I was using as in the class example in SAS, the 25th and 70th percentile were different than they were calculated in SPSS. So except for the median, which everybody agrees on, it turns out in R, using the quantile function, there are 9 different algorithms that you can choose. I forget how many there are in SAS and in SPSS, but just know a percentile is not a percentile is not a percentile. So it's entirely possible when you're reading papers and people report percentiles, you kind of ought to try to figure out how they calculated that percentile. It usually doesn't change drastically. Usually where you run into problems is if the data is really small, like there's not a lot of data there, or like the data has some kind of wonky distribution. So I just point that out, just be aware. And sometimes it's worth going and finding out what algorithm the software is actually running. You guys already saw this. You can change the quantile for probabilities if you want. I do want to point this out. So you'll see this occasionally, where you'll see a variable with the tilde. That's that funky sort of sideways S. And this shows up in a couple of different places. You're definitely going to see it in the workshop in August when I talk about modeling. What this says is, I want to see age modeled as a function of race. From a box plot perspective, what it says is, give me the box plots by race. And so if I run this, I'll get the box plots for each of my race groups. And this is just the QQ plot, ggplot2 approach to doing that. So it looks very, very similar to what we had for histogram. The only difference is, and I've never quite understood this, but this is where learning ggplot has a bit of a learning curve initially. And this is why I always have to go look stuff up in books like that. So the X here is basically set to like an empty variable. It's like these are two quotes with nothing in the middle. So the X is empty, and I set Y equal to age. If I leave X blank and don't have anything here, I'm going to get an error in ggplot. So, so to get that box plot, it really wants this value, and it's assuming I want to see those box plots by something. If I just want to see the box plot for age by itself, I have to like set X equal to like null. It makes more sense down here if I look at age by race and then run this. Now the X makes sense. But if for some reason you want to get a standalone box plot using ggplot, you have to set the X equal to null. So if you want just a single box plot, just use the base box plot function command. There's some others. There's some violin plots. So remember I was talking about this whole idea like you change the geom and you get a different plot. So if I just swap that out and use something called a violin plot, you guys ever seen those? They're kind of cool. They look like a bunch of little violins. There's some other things here that I've added little dots and like a legend and stuff. So these are all examples out of that cookbook that you guys have right there. So like here's violin plots by age with all the little dots overlaid. Turns out there's another package out there called violin mplot. This is how that works. And here's a way to look at sort of frequencies using sort of a ggplot approach. And then there's more of the same down here. So I've got stuff here just to show you, and you guys can spend some time doing this on your own. Scatter plots. There's a function in base R called scatter.smooth, which will take a scatter plot and overlay a smooth fit line. This is sort of the inside of ggplot. There's actually some of these like what I would call shorthand plotting functions, one of which is qplot. Will actually do a similar kind of plot without the dots. So there's just a smooth fit line comparing the CESD and the MCS. And actually these are highly correlated, just so that you know. So depression and the mental component scale of the SF-36 are often highly correlated because they both reflect sort of mental health status. They're just slightly different measurements. I might do this a little bit more when we do the regression session next time, but this is a way to kind of get started doing correlation. So in base R, there's a function called COR, and all I'm doing here is basically pulling out the continuous variables. So instead of, like I dropped female and race group, I've got age, CESD, PCS, and MCS. So I've created sort of a variable subset, and that's what I'm doing here is pulling out a variable subset. And it turns out you can look at Pearson, Spearman, or Kendall's tau. So you can, by default, I think it gives you Pearson's correlation, but it is kind of handy sometimes to get the non-parametric correlations too. And then there's another function from the psych package called core.test that I'll show you here real quick. So these just give you the correlations. This doesn't give you the p-values, and it doesn't tell you the sample size. So like if you have intermittent missing data, sometimes it gets kind of confusing what the final sample size was. The core.test function from psych gives you a little bit more output. So the top output here is the correlation matrix, and these are the p-values. So almost all of these are significant, except for like age and depression are like not correlated, and then the age and the MCS aren't really correlated. But like age and PCS are negatively correlated, so the older you are, the less physical functioning you have, and the p-value here is significant.
Is there a way to get like the p-values, like if it was
more decimals?
Yeah.
I think there is. I need to look up. There's probably a way to set the number of digits Let me just see if I can do that. Let's see if I type in core.test. Sometimes you can do it inside the function. Let's see, adjust. Not here. I think, here, I tell you what, actually, so to answer your question, this just sends it straight to the screen. If I want to save these results, so I'm going to save them and stick them in an object called PC, which shows up right here. So it's a list of 11 values. So it turns out there's like R, N, T, P, and stuff. So the P values here are to much greater detail. So like if I do this, this is like any other object. So like I could just look at the correlations. If I look at the P values, oops, I'm not really sure why that, wow. It went way off the screen. So yeah, I'm not really sure why it gave me quite that many digits. There's probably a way to control that a little bit better. But yeah, so like this P value is really, really small. Yeah, so this one went way off the screen. So it's highly, highly significant. And it turns out when you do those correlation tests, those are actually t-tests. So if you remember way, way, way back when you first learned that, if for some reason you wanted those test statistics, you could pull them out. You can actually get the confidence intervals for the correlations, which these are sometimes really handy to know. So like, for example, the correlation between, say, age and PCS. The value was minus 0.22, 8 or so, but the confidence interval is from minus 0.31 to minus 0.14. So every now and then publications want those confidence intervals. So this is a way to start teasing some of that stuff out.
And then from that data, you could put it into like a heat map or something.
Yes, and I'm going to talk about visualizing some of those correlations and heat maps. I was going to do that for the regression lecture because you kind of start with correlations. The rest of this lecture, just so you guys can see it, has some things here like what do you do with a continuous variable with a two-group categorical? That's a t-test. So correlation test is one, but there actually is a function in R called t-test, and it says give me age modeled as a function of, in this case, gender, which female is 1, male is 0. That's why it's called female. And then what data set am I pulling it out of? You could look at the CESD by gender. So like if I ran that one, the CESD by gender, and it runs by default what's called the Welch two-sample t-test. By the way, this is one place that R differs from a lot of other packages. It by default runs the unpooled t-test. If you want the pooled t-test, you have to turn that on, or you have to set that option to true. So like if I type in t.test, and it'll tell that to you in here, performs 1 and 2 sample t-tests on data, where it says not alternative. Let's see, hold on. Variance.equal equals false. So it's assuming that the variances are unequal. So it's running the unpooled t-test. If you want the pooled t-test, you have to say variance equals true. So there's some of this kind of stuff that's just, you kind of have to get into R and start using it. You got to read through the help system, get a couple of really good books. This is the other book that, let me just, since we're wrapping up here, is another fantastic book, I think, for learning R, simply because he also has a great website. So this R in Action book, it's done by Manning, and the guy's name is Robert Kabakov. So this is the book, and his website is Quick R. And so the great thing about this one, it has some stuff, just some basics. It does have an R tutorial. So for example, under statistics, if I click on statistics and I want to learn how to do a t-test, here you go. So it's very user-friendly. He has really good examples and good explanations, especially with his book. And his book not only provides code examples and stuff, but most of the time when he has code, let me see if I can find a good example for you guys. He usually has it really well annotated. Although I've also annotated it. I've written all over it. I'm not going to be able to find a good one. Oh, well, like here's an example. So like he has a little script here, and this is showing a dot plot grouped and sorted with like some colored data. And so he shows the code, and then he walks you through, and then he has explanations all the way through. And then usually there's like, this is the code, this is the plot. A little bit later on, when he gets more into analysis, he talks a little bit about interpretation. He's not quite to the level of like Andy Field, where he shows you the code and the data example, and then he has the output, and then he shows you how to write it up in APA format. And so it's not quite to that level, but any code that he has in here like that with little code scripts, he's got it really well annotated. And I just like his examples are really easy to follow and adapt for other examples. So, and then you've got his whole website to go with it. So I think I'll probably stop there. This shows that these are non-parametric, like t-test equivalent. And then here's categorical data. Remember way back up, I showed you guys that G-models cross table. So this is where you can get chi-squared and Fisher exact test output. So like if I was looking at race by gender or something like that. And this little code section right here, I went through, made gender a factor, and then right here I'm like recoding. I ended up merging Hispanic and other together. You could have left it separate, but it turns out that one of those categories is really low, and when you do that, like you can't get a good chi-squared test. You'd have to do Fisher's exact or something because the cells are too small. There's just not enough. So this is me recoding and collapsing data together. So just play with that. All right, so let me stop my